Welcome to my YouTube channel. We're going to see how we can use a new and easy method to derive the quadratic formula. Now we're given the equation y equals to ax squared plus bx plus c, where a is not equal to 0. Now it can be shown that this equation has an axis of symmetry from the geometric interpretation. That is this line over here. You can see this line over here, this vertical line. The equation of this vertical line is x equal to minus b over 2a. The curve is symmetrical about this vertical line. That's its geometrical property, the geometrical property of the quadratic function. Now, some of you know how to derive the quadratic formula from using and completing the square method. But today we're going to see a much easier method using the axis of symmetry method. Some call it the mid-distance method. Some call it Dr. Loh's method. Okay, so let's assume that alpha and beta are the roots of the quadratic equation. Now, geometrically, the point where the curve cuts the s-axis, this is the y-axis, this is the s-axis. These points and these points are the solutions or roots. So whatever point your curve cuts the x-axis are 2 points, alpha and beta, alpha at the left hand side and beta at the right hand side. Those 2 points are your solution. In this case, we have distinct and real roots. Now let's consider 3 points. The first point is the axis of symmetry, s equal to minus b over 2a. The next point on the left hand side, s equal to alpha. And then on our right hand side, s equal to beta. Alpha is at a distance u from this point. From this point to this point is u. From this point to this point is u. Because of the symmetric nature of the quadratic function. So we're going to take the distance from here to this point u, and to also be the same as this. So how can this be useful to us? So because of alpha is taken to be at the left hand side, we're going to be subtracting u to get alpha. And similarly, we're going to add u to get beta, because they are on both sides of the axis of symmetry. Now we're going to multiply them, alpha times beta, to obtain c over a, which is the relationship given earlier, although the proof was not given, but we're going to see the proof in our next video. So we're expanding, we'll have this expression. So this can cancel off. So we're left with this. Now, you notice we have b square, we have 4, which can be written as 2 square, a square, and we have u square. So this is what we call a difference of 2 squares expression. So we'll make u the subject of the equation. We obtain this. Then we simplify, and then we'll take square root of both sides. So that's u is equal to square root of b square minus 4 is equal to a. So we're interested in the principal square because we're interested in u. U is a distance, a positive number. So we'll take only the positive square root, which is principal square root. So we combine alpha beta, so we have plus or minus u, which is this. So we obtain these results. They have equal denominator, so we can take one and then add up the numerators. And then you recognize this. You notice we have derived the quadratic formula very easily. Very simple way to derive it. So that's this. So far, what do we do? We use the axis of symmetry, and then we also use the fact that the product of the roots is c over a, where c is the constant term. And so future videos will see how we can derive this expression, the equation of the axis of symmetry, and then the expression, the equation for the product of the roots. So please subscribe to my video. Like, share, and subscribe. You can see the subscribe button down, so just click on it. So thanks for watching.